Welcome to Trinath Chemistry classes. In this video, I am going to discuss about the intermediate first year organic chemistry topic hydrocarbons. In hydrocarbons topic, I am going to discuss about preparation of alkenes. We know that the compounds having carbon and hydrogen are called hydrocarbons, and these hydrocarbons are again classified into two types: open chain compounds and closed chain compounds. In open chain compounds are also called as aliphatic compounds. These aliphatic compounds are divided into two types: one is saturated and another is unsaturated. So in this hydrocarbons content, I am going to discuss about preparation of alkenes. And this topic is important not only in intermediate public examination point of view, in IIT, JEE mains, MSET, EPSET and NEET examination point of view also. This topic is most important. Please like the video, share and subscribe the channel. What are hydrocarbons? We know that hydrocarbons are the compounds having carbon and hydrogen are called hydrocarbons. What are hydrocarbons? Hydrocarbons are the compounds having only carbon and hydrogen are called hydrocarbons. And we know that these hydrocarbons are divided into two types. One is open chain compounds and another one is closed chain. Another one is closed chain. Open chain compounds and closed chain compounds. So open chain compounds are also called as aliphatic compounds. Aliphatic compounds. And the open chain compounds means in which carbon chain extends as long as possible. It won't form a cyclic ring or something. Those are called open chain compounds. And these open chain compounds are further divided into two types. One is saturated, another one is unsaturated. Another one is unsaturated. Another one is unsaturated. So, what are saturated open chain hydrocarbons? What are unsaturated open chain hydrocarbons? Means we know that carbon has a valency of 4. Carbon has a valency of covalency of 4. It can form 4 bonds with other carbons or with the other elements. Right? If you take carbon, 4 valencies are filled with only carbon single bonds, then it is called a saturated hydrocarbon. It is called a saturated hydrocarbon. All the valencies of carbon are filled only with carbon single bonds. Those are called saturated. If any double bond or triple bond are present between the carbons, those are called unsaturated. Those are called unsaturated open chain hydrocarbons. Means saturated hydrocarbons means the organic compounds having carbon and hydrogen, and in which all the valencies of carbon are only filled with the carbon single bonds. Those are called saturated hydrocarbons. If it contains carbon double bond or triple bond, those are called unsaturated hydrocarbons. These unsaturated again are classified into two types. If it is double bond containing, those are called alkenes. If it contains triple bond, those are called alkynes. And examples for this saturated hydrocarbons are alkanes. Alkanes are the examples for the saturated hydrocarbons. Alkenes are the compounds having carbon double bond. Unsaturated hydrocarbons having carbon double bond are called alkenes. Unsaturated hydrocarbons having carbon triple bond are called alkynes. Right? In my previous video, this is my second video in this hydrocarbons content. In my first video, I have discussed about the various preparation methods of the alkenes. In this video, I am going to discuss about preparation of alkenes. Preparation of alkenes. So alkenes are also called as olefins, and these are having general formula CnH2n. These are having general formula CnH2n. Alkenes are the unsaturated hydrocarbons containing carbon-carbon double bond, and these are also called as olefins. These are also called as olefins, and their general formula is CnH2n. CnH2n. Right? Here, alkenes, if you observe in alkenes, these are the compounds having carbon-carbon double bond, in which carbon atom undergoes sp2 hybridization. The carbon atom undergoes sp2 hybridization. In alkenes, the carbon-carbon having double bond, that carbon undergoes sp2 hybridization. Undergoes sp2 hybridization. So first preparation of alkenes. Preparation of alkenes. Alkenes. So the first method is from alkyl halides. From alkyl halides. Alkyl halides. We know that alkenes are the saturated hydrocarbons. They are having CnH2n plus 2 as their molecular formula. If one of the hydrogen is removed, that group is called alkyl group. The group is called alkyl group. For example, CH4 is the methane. CH4 is the methane. If one hydrogen is removed, it is called methyl. It is called methyl. It is called methane methyl. It is called methyl. Right? Here, alkyl halides means in alkenes, if one hydrogen is replaced with halogens, those are called alkyl halides. Those are called alkyl halides. Alkyl halides means in alkenes having molecular formula CnH2n plus 2. If one of the hydrogen is replaced with halogen, halogen means fluorine, chlorine, bromine, iodine are called halogens. One of the hydrogen is replaced with halogen. Those are called alkyl halides. So the first preparation method is from alkyl halides. Preparation method is from alkyl halides. Alkyl halides, if you take, when alkyl halides are treated with alcoholic KOH, alcoholic KOH, alkenes are formed. Alkenes are formed. When alkyl halides are treated with alcoholic KOH, alkenes are formed. For example, if you take C2H5Br, so this is called bromoethane or ethyl bromide. When treated with alcoholic KOH, alcoholic KOH or alcoholic NaOH means when if KOH is dissolved in water, it is called aqueous KOH. If it is dissolved in alcohol, it is called alcoholic KOH. When alkyl halides are treated with alcoholic KOH, here dehydrohalogenation takes place. Dehydrohalogenation takes place. That means a removal of hydrogen and halogen from the adjacent carbons and forms carbon-carbon double bond. CH2 double bond CH. Here, what is happening is, you see CH2, CH2. So if you observe in this, from this carbon, hydrogen atom is removing, and from this carbon, bromine is removing, and HBr going out. That's why this is called dehydrohalogenation. Dehydrohalogenation. When alkyl halides are treated with, alcoholic KOH, dehydrohalogenation takes place. That is elimination of HX. Removal of HX takes place and alkenes are formed. So this reaction, we are calling it as the dehydrohalogenation of alkyl halides. Dehydrohalogenation of alkyl halides. Dehydrohalogenation of alkyl halides. So one interesting fact is the same alkyl halides, when treated with aqueous KOH, here nucleophilic substitution occurs. Nucleophilic substitution occurs, reaction occurs, and alcohols are formed. The same alkyl halide, when treated with alcoholic KOH, here elimination reaction occurs. And alkenes are formed. When alkyl halides are treated with aqueous KOH, here nucleophilic substitution reaction occurs and alcohols are formed. When the same alkyl halides are treated with alcoholic KOH, here elimination reaction occurs, that is removal of hydrogen halide, that is dehydrohalogenation occurs, and alkenes are formed. Here, in objective point of view, we need to know some certain things. One is the reactivity of alkyl halides towards dehydrohalogenation is tertiary alkyl halides are more reactive than secondary alkyl halides, which are more reactive than primary alkyl halides. We know that the carbon attached to only one carbon is called a primary carbon. A carbon attached to the two other carbons is called a secondary carbon. Carbon attached to the three other carbons is called tertiary carbon. If halogen is attached to the primary carbon, it is called primary alkyl halide. If halogen is attached to the secondary carbon, it is called secondary alkyl halide. And halogen is attached to the tertiary carbon, it is called tertiary alkyl halide. Is it this dehydrohalogenation of alkyl halides? If you observe the reactivity of various alkyl halides, tertiary is more reactive than secondary, which is more reactive than primary. In case of among the different halides, alkyl iodides are more reactive than alkyl bromides, which are more reactive than alkyl chlorides. Among the alkyl halides, among the different alkyl groups, tertiary is more reactive than secondary, which is more reactive than primary. Among the halides, iodides are more reactive than bromides, which are more reactive than chlorides. So let me give you some examples. Then we can understand how to write the final product. For example, if you take 2-bromopropane, 2-bromopropane, when treated with alcoholic KOH. See here, elimination occurs. That's why here from this carbon, hydrogen will be removed, and from this carbon, bromine will be removed, and between these two, double bond will be formed. So this is called propene. Suppose, let me give you one more example. CH3, CH2, CH2, CH2. When treated with alcoholic KOH, what happens? Here, from this carbon, bromine will be removed. From this carbon, hydrogen will be removed, and you will get the final product of CH3, CH2, CH double. So this is the 1-butene. This name is 1-butene. Its name is 1-butene. So here, dehydrohalogenation of alkyl halides. This is the one of the important method for the preparation of alkenes. Let me explain you some more examples. CH3, CHBr, CH2, CH. So its name is 2-bromobutene. Its name is 2-bromobutene. When it is treated with alcoholic KOH. When it is treated with alcoholic KOH. Here, if we observe, there is a chance of removal of the two hydrogens. One is from the carbon 1, another is from the carbon third carbon. If from one carbon, if carbon 1, if it is hydrogen is removed, then we will get the final product of CH, CH2, CH. It is 1-butene. And suppose if the third hydrogen is removed, then what will happen? CH3, CH, CH. It is called 2-butene. It is called 2-butene. It is called 2-butene. Now, which one is formed as the major product? So here, 2-butene is the major product and 1-butene is the minor. So why it is the major product? Why it is the major product? This can be explained with the help of Sergeff rule. Which rule? Sergeff rule. Which rule? Sergeff rule. According to the Sergeff rule, in dehydrohalogenation, if more than one alkene is formed, in dehydrohalogenation, more than one alkene is formed. More than one alkene is formed. So according to this Sergeff rule, in dehydrohalogenation, if more than one alkene is formed, then the preferred product is the preferred product is the alkene that has greater number of alkyl groups attached to the doubly bonded carbon atom. Doubly bonded carbon atom. Preferred product is the alkene that has greater number of alkyl groups attached to the greater number of alkyl groups attached to the doubly bonded carbon atom. Attached to the doubly bonded carbon atom. Doubly bonded carbon atom. The what this Sergeff rule, according Sergeff rule states that in dehydrohalogenation of alkyl halides, if more than one alkene is formed, the preferred product is the alkene that has greater number of alkyl groups attached to the doubly bonded carbon atom. Doubly bonded carbon atom. Doubly bonded carbon atom. Or simply we can say that the hydrogen will be removed. The hydrogen will be removed from the carbon having less number of hydrogen. That if when that hydrogen goes, the product forms as the major product. The hydrogen will be removed. The hydrogen will be removed from the carbon having less number of hydrogens. Then that hydrogen removed product is the major product in dehydrohalogenation. Dehydrohalogenation. So this is regarding first method, dehydrohalogenation of alkyl halides. Dehydrohalogenation of alkyl halides. Then second method is from alcohols. When alcohols are treated with concentrated H2SO4. Alcohols are treated with concentrated H2SO4 at 170 degrees centigrade, you will get alkenes. Here, elimination reaction occurs, that is dehydration, that is removal of water. Dehydration, that is removal of water. Removal of water occurs and alkenes are formed. Alkenes are formed. When alcohols are treated with concentrated H2SO4 at 170 degrees centigrade, dehydration or dehydration reaction occurs and alkenes are formed. Alkenes are formed. For example, if you take CH3, CH2OH and treated with concentrated H2SO4 at 170 degrees centigrade, OH group will be removed from this carbon, hydrogen will be removed from this carbon, and like this alkenes are. Like this alkenes are. For example, if you take CH2, CH2OH, so here the product is CH3, CH double bond, CH. So here the dehydration of alcohols. When alcohols are treated with the concentrated H2SO4, concentrated H2SO4 at 170 degrees centigrade, dehydration reaction occurs and alkenes are formed. Alkenes are formed. Here, among the given alcohols, the tertiary alcohols are more reactive than secondary, which are more reactive than primary alcohols, which are more reactive than primary alcohols. Among the alcohols, similarly, whatever I told you for alkyl halides, if OH group is attached to the tertiary carbon, those are called tertiary alcohols. If OH group is attached to the secondary carbon, are called secondary alcohols. If OH group is attached to the primary carbon, are called primary alcohols. Primary alcohols. So among the alcohols, tertiary alcohols are more reactive towards dehydration when compared to secondary, which are more reactive when compared to the primary alcohol. When compared to the primary alcohol. So this is second one from alcohols. Now the third one is dehalogenation of vicinal dihalides. Vicinal dihalides. Dehalogenation of vicinal dihalides. Vicinal dihalides. We know that if adjacent carbons having two halogens, those are called vicinal dihalides. If same carbon having two halogens are called jump dihalides. Jump dihalides. Vicinal dihalides and jump dihalides. So if two halogens are present on the adjacent carbons, those are called vicinal dihalides. If two halogens are present on the same carbon, are called jump dihalides. When vicinal dihalides are treated with vicinal dihalides are treated with zinc dust in acetic acid. Zinc dust in acetic acid. Dehalogenation occurs. Dehalogenation occurs and alkenes are formed. Alkenes are formed. When vicinal dihalides are treated with zinc dust in acetic acid. Here what is happening is dehalogenation. Halogenation means addition of halogen. Dehalogenation means removal of halogen. For example, if you take 1,2 dibromoethane. 1,2 dibromoethane with zinc in the presence of acetic acid. In the presence of acetic acid, what is happening is this bromines are removing. That's why here you will get CH2 double bond CH2 plus ZnBr2. So this is nothing but dehalogenation of vicinal dihalides. Vicinal dihalides. Here, zinc acts as a reducing agent. Zinc acts as a reducing agent. Zinc acts as a reducing agent. That's why it is oxidized to ZnBr2. ZnBr2. This is about dehalogenation of vicinal alkynes. And the next one is from alkynes. From alkynes. Alkynes. We know that alkynes are the carbon-carbon having triple bond are called alkynes. When alkynes are treated with, when alkynes are treated with, alkynes are treated with H2 by palladium by barium sulfate. H2 by palladium by barium sulfate or H2 by palladium by barium carbonate. We are calling it as the Lendlar's catalyst. We are calling it as the Lendlar's catalyst. When alkynes are treated with Lendlar's catalyst, H2 by palladium by barium sulfate or H2 by palladium by barium carbonate, we are calling it as the Lendlar's catalyst. When alkynes are treated with Lendlar's catalyst, you will get cis alkenes. Cis alkenes. We know that alkenes exhibit geometrical isomerism. So this is cis alkenes. We will get cis alkenes. Here we need to remember what is Lendlar's catalyst. H2 by palladium by barium sulfate. H2 by palladium by barium sulfate. The same treated with sodium by liquid ammonia. Sodium by liquid ammonia. Here also we will get transalkene. Transalkene. We know that what is cisalkene and what is transalkene. We know that what is cisalkene and what is transalkene. Cisalkene means if same type of groups are present on the same side of the carbon are called cisalkenes. If the same groups are present on the different sides of carbon are called transalkenes. Transalkenes. When alkenes are treated with Lendlar's catalyst or sodium by liquid ammonia, partial hydrogenation occurs. Partial hydrogenation occurs. Partial hydrogenation means to become a saturated, it has to be react with the two hydrogens. But here only for one hydrogen only they are reacting. That's why it is called partial hydrogenation. So when alkynes are treated with H2 in the presence of platinum or palladium or nickel or any other catalyst, nickel, you will get initially you will get alkenes, but immediately they further react and forms alkanes. Alkanes. You won't isolate the alkenes when alkynes are treated with hydrogen in the presence of palladium, platinum, or nickel. Palladium, platinum, or nickel. So to stop at the alkene stage, we need to do partial hydrogenation. Here, to do partial hydrogenation, the reagents are Lendlar's catalyst and sodium by liquid ammonia. Sodium by liquid ammonia. This is from alkanes. This is from alkynes. Then next one is coal-base electrolysis. Next one is coal-base electrolysis. What is this coal-base electrolysis? We know what is electrolysis. Electrolysis is decomposition of a substance by passing electricity. We are calling it as electrolysis. What is coal-base electrolysis? Coal-base electrolysis. When sodium salts of sodium or potassium salt of dicarboxylic acids. Dicarboxylic acids. Potassium salts of dicarboxylic acids on electrolysis gives alkenes. Gives alkenes. When sodium or potassium salts of dicarboxylic acids are electrolyzed, means when electricity is passed through the aqueous solution of sodium or potassium salts of dicarboxylic acids, electrolysis occurs and alkenes are formed at the anode. Alkenes are formed at the anode. Alkenes are formed at the anode. Let me take one example. For example, CH2, COO minus K plus, CH2, COO minus K plus. Here on electrolysis, we will get CH2 double bond CH2. CH2 double bond CH2. So this reaction we are calling it as the coal-based electrolysis. In coal-based electrolysis, when the sodium salt, potassium salts of carboxylic acids are electrolyzed or passed through, or the electricity is passed through the aqueous solution of sodium or potassium salts of carboxylic acids, alkenes are formed at the anode. Alkenes are formed at the anode and hydrogen will be liberated at the cathode. Hydrogen will be liberated at the cathode. So in objective examination point of view, in coal-based electrolysis, alkene is formed at anode and the product liberated at cathode during coal-based electrolysis is hydrogen. Coal-based electrolysis is hydrogen. So this is the fourth method. This is the fourth method. First one we have seen from alkyl halides. Second one is from alcohols. Third one is from vicinal dihalides. Fourth one is from alkynes. And fifth one is coal-based electrolysis. Coal-based electrolysis. So these are the preparation methods for the preparation of alkenes. For the preparation of alkenes. Thank you for watching Trinath chemistry classes. Please like the video, share and subscribe the channel.